अस्सलाम वालेकुम सर।
वालेकुम अस्सलाम। ऐसे स्टार्ट करना है क्या? 3 पार्टिसिपेंट हैं ज्वाइन।
जी सर।
एक, 1 मिनट रुकेंगे हम, और 2-3 आ गए ना स्टार्ट कर देंगे, जब तक हम थोड़ा सा रिवीजन लेंगे इसका। सो गुड मॉर्निंग टू ऑल। माई सेल्फ शोएब पीरजादे, असिस्टेंट प्रोफेसर, डिपार्टमेंट ऑफ केमिस्ट्री, मिलिया आर्ट्स साइंस एंड मैनेजमेंट साइंस कॉलेज, बीड. We are discussing on, that is thermodynamics second. In the previous periods, we have studied, that is various statements of second law of thermodynamics. Then we have seen Carnot cycle. Carnot cycle work in 4 steps. We have seen isothermal expansion, adiabatic expansion, isothermal compression, and adiabatic compression. So we have obtained total work done in Carnot cycle. Then we have seen, that is Carnot's theorem. There are 2 Carnot theorem. Carnot theorem first and Carnot theorem second. We have also proved. Then efficiency of Carnot cycle, that is efficiency is equal to T2 minus T1 upon T2, and that is work done is given as W upon Q2 is equal to T2 minus T1 upon, that is the T2. And we have solved numerical problems on this, that is the Carnot theorem. So up to this, in the last period we have discussed. Now today we are study, or that is explain the concept of entropy. That is, what is entropy. Now in first law of thermodynamics we have study, that is enthalpy. We have study enthalpy. Yes, so in first law the concept of enthalpy is there, while in second law of thermodynamics, that is the concept of entropy is there. Concept of entropy. So enthalpy, we have seen enthalpy. Enthalpy is denoted by, what is the symbol of enthalpy? Yes, can anybody tell me enthalpy की symbol क्या है? First law में हमने स्टडी की है enthalpy, या उसका इक्वेशन बताइए, या किससे डिनोट करते हैं? क्या can anybody tell me the enthalpy? Enthalpy is denoted by, that is the S capital H. We have seen it is the total heat content. एंथैल्पी देखा है हमने, that is एंथैल्पी को हम S से डिनोट करते हैं, और उसके लिए फॉर्मूला है H is equal to E plus PV or U plus PV. We have seen. So that is the concept of enthalpy in first law of thermodynamics. यानी first law of thermodynamics में हमने एंथैल्पी का कंसेप्ट स्टडी किया है। और यहां पर आपको जो है एंट्रोपी, दोनों सेम है। देखिए इन फर्स्ट लॉ वो भी हीट है, दैट इज एंथैल्पी, इट इज द टोटल हीट कंटेंट ऑफ द सिस्टम। और एंट्रोपी, एंट्रोपी भी हीट की किस्म है, इट इज ऑल्सो ए दैट इज heat content of the system. But what is the difference we see, that is first entropy. एंट्रोपी को हम सबसे पहले हम ये करेंगे, जैसा एंथैल्पी है, एंथैल्पी को हम जो है कैपिटल एच से डिनोट करते हैं। तो एंट्रोपी यहां पे देखिए, एंट्रोपी इट इज डिनोटेड बाय कैपिटल एस, रिमेंबर दैट, एस से डिनोट करते हैं एंट्रोपी को। आगे आएगा हम देखेंगे, दैट इज एंट्रोपी, एंट्रोपी इज डिनोटेड बाय दैट इज कैपिटल एस, और चेंज इन एंट्रोपी दैट इज द डेल्टा एस। Now, to explain this, so consider a Carnot cycle ABA consisting of two isothermal and two adiabatic steps. So see in this diagram, that is, it is given, it consists of a Carnot cycle A. See A, it go to here B. Now again it go to, that is the A. So it become a Carnot cycle. So this A go to B, and again this B go to, that is here, that is the A. So we have considered here, that is a Carnot cycle ABA. So it is shown in the diagram, that is this A, this is ABA. See the diagram, that is ABA. It is a Carnot cycle, and this Carnot cycle consisting of two, that is isothermal, and two adiabatic steps. You know that is what are the two isothermal steps and two adiabatic steps, that is isothermal expansion and isothermal, that is isothermal expansion, and second is, what is the second? Isothermal compression. Second isothermal is, can anybody, what are the four steps of Carnot cycle? Isothermal expansion, second adiabatic expansion, third one isothermal compression, and fourth one adiabatic compression. So these are the four steps we have seen. Thus the cycle can be divided into great number of infinitesimally small Carnot cycle. When we consider, that is a Carnot cycle ABA consisting of two isothermal and two adiabatic step, and this cycle can be divided into great number of, that is infinitesimally small Carnot cycle. So see, these are the great number of infinitesimally small, that is the Carnot cycle. These are the, that is great number of infinitesimally small Carnot cycle. Now the smaller the cycle, the more closely they follow the path of general cycle. That is, if the smaller the cycles, the more closely they follow the path of the general cycle. All the work and heat, all the work and heat terms arising from this small cycle, and only the sum of SUM, sum addition, that is of Q upon T, the sum of Q upon T arising from the outside zigzag. Outside the zigzag means, see here, this, which part of the outside the Carnot cycle? देखिए यहाँ पर आपको, this is ABA is the Carnot cycle. Outside the Carnot cycle यानी साइकिल के बाहर है क्या पार्ट, कुछ इसमें है यहाँ पर देखिए, this part, this part, this part. So this is the outside the part. Here also this part, this part, this. So it is like a, that is the zigzag. Outside the zigzag, isotherm must be considered. So all the work and heat terms arising from this small cycle, and only the sum of Q upon T arising from the outside zigzag isotherm must be considered. On the basis of this assumption, we may write for an arbitrary cycle. So see here, that is Q upon T. So if great number of, that is infinite number of that cycle is there, and this sum can be given as, that is Q upon T, where Q is the heat absorbed and T is the temperature, absolute temperature. So it can be given as, that is Q1 upon T1, Q1 upon T1 plus Q2 upon T2 plus Q3 upon T3 plus dash dash. So this is the sum of Q upon T terms, that is from the outside zigzag isotherm. Q1 upon T1 plus Q2 upon T2 plus Q3 upon T3 plus dash dash. And it can be written as in the mathematical form. How it can be written as? It is summation. So it can be written as, this symbol is summation. Summation of, मैथ्स वाले अच्छी तरह से जानते हैं, देखिए, और 12 11 10 तक भी हुआ है, 11 12 में भी है सिंबल, दैट इज समेशन. किसकी समेशन है? समेशन ऑफ Q अपॉन T. समेशन ऑफ Q अपॉन T. ये आपको इतना Q1 T1 प्लस Q2 T2 प्लस Q3 T3 प्लस डैश डैश लिखने के बजाय आप लिख सकते हैं समेशन ऑफ Q अपॉन T. Summation of Q upon T, and it equal to 0. It is equal to 0. So summation Q upon T is equal to 0. And in the limit of infinitesimally small reversible cycle, and in the limit of infinitesimally small reversible cycle, that is for small change, we can write summation dq. D is the small change, so for that we have taken here D. सेम है, खाली आप क्या करना है यहाँ पर देखिए, Q से Q is we have taken infinitesimally small reversible cycle. So for infinitesimally small cycle we can take here D, small change. Small change के लिए हम यहाँ पे D लिखे हैं. So dq upon T. So this can be read as summation dq upon T is equal to 0. This equation describes a new thermodynamic function. This equation describes a new thermodynamic function, and that can be given as, that is ds is equal to dq reversible, rev means reversible process, that is heat absorbing reversible process. Remember that dq rev means dq means heat and rev means reversible. Heat absorbed in reversible process divided by T. So this is the, that is a formula for, that is the entropy. This is the formula for entropy, that is ds is equal to dq reversible divided by T, where ds is the entropy change, dq reversible heat absorbed in reversible process, and T is the, that is a temperature. So that is formula for entropy is ds is equal to dq reversible upon T. We can calculate the change in entropy. Change in entropy when heat absorbed in reversible process is given and absolute temperature is given. Problem में भी प्रॉब्लम भी आता, देखिए change in entropy मालूम कीजिए, heat absorbed in reversible process is given, यानी dq reversible की वैल्यू दी हुई है और T की वैल्यू दी हुई है, तो put the values, we can calculate the change in entropy. Now this function was first introduced by Clausius. This function, that is ds या entropy का जो function है, ये Clausius नामी साइंसदान ने इंट्रोड्यूस किया and called entropy. So it is called as the entropy. So आपका जो एक क्वेश्चन नंबर 3 में मल्टीपल चॉइस क्वेश्चंस आते हैं, तो उसमें क्वेश्चन पूछा गया है, देखिए कि द कंसेप्ट ऑफ एंट्रोपी इज इंट्रोड्यूस्ड बाय डैश. एंट्रोपी का कंसेप्ट कौन से साइंटिस्ट ने इंट्रोड्यूस किया? सो रिमेंबर दिस, क्लासियस. ऑब्जेक्टिव टाइप में 1 मार्क के लिए पूछा गया है यूनिवर्सिटी एग्जामिनेशन में, दैट इज द कंसेप्ट ऑफ एंट्रोपी इज इंट्रोड्यूस्ड बाय डैश. Different options are given, that is Kirchhoff's, then Einstein's, then Clausius, etc. So that is the Clausius. Remember that is the concept of entropy. The concept of entropy is introduced by, that is the Clausius, and it's a formula, that is change in entropy is equal to dq reversible upon T. Very simple. That is heat absorbed divided by, that is the absolute temperature, that give the entropy. Remember this formula. That is ds is equal to dq reversible upon, that is the T. Okay, so this function was first introduced by Clausius and called, that is the entropy. Now different cases of entropy we have to see here. First is entropy change of the thermal surrounding. यानी thermal surrounding में entropy क्या होती है? दैट इज एंट्रोपी चेंज ऑफ द थर्मल सराउंडिंग। थर्मल सराउंडिंग में एंट्रोपी के लिए क्या फॉर्मूला है, और व्हाट इज द वैल्यू ऑफ एंट्रोपी इन थर्मल सराउंडिंग। द एंट्रोपी चेंज of the surrounding can be calculated by a suitable integration of, see here, the entropy change of thermal surrounding can be given as ds is equal to ds of system. Ds means that is change in entropy. Ds of system is equal to du of therm, that is change in internal energy, as therm is thermal, therm, therm is thermal, that is change in internal energy. Du is change in internal energy divided by that is the T. So this is the, that is entropy change of thermal surrounding, that is the du thermal divided by T. So this is the, that is a formula for entropy change in thermal surrounding. That is entropy change in thermal surrounding can be given as ds of system. Ds is change in, that is entropy, is equal to du of thermal, du internal energy, therm is, that is the thermal, that is heat, divided by T. So this is the entropy change in thermal surrounding. Now second, entropy change of the mechanical surrounding. Mechanical surrounding में entropy change की value क्या होती है? So very simple, that is entropy delta S of mechanic. Mech means mechanical surrounding. So delta S of mech is equal to 0. यानी entropy change in mechanical surrounding is always 0. So this question may be asking objective type, that is entropy change in thermal surrounding is dash dash. So, sorry, mechanical surrounding. Entropy change of the mechanical surrounding is dash dash. कितनी होती है? 1, 0, 2 or other options. So remember that, that is entropy change of mechanical surrounding is always, that is the 0. Or it can also be written as ds, ds change in, that is the entropy. ds of mech is equal to 0. Mech means mechanical surrounding. Remember that. In short, it is written as MECH. So this is the, remember that entropy change of mechanical surrounding is always 0. Remember that. Now third one, entropy change of the system when the process is carried out reversibly is 0. That is entropy change of the system when the process is carried out reversibly is 0. Now entropy change, that is delta S. Now, simply entropy is denoted by S. और अगर change है तो we can take here delta S. What is delta S? Change in entropy. जैसा change in volume we can denote delta V. Change in pressure delta P. So change in temperature delta T. So similarly we can write the entropy change is delta S. डेल्टा एस, रिमेंबर दैट, आगे आएगा आपको बहुत मतलब डेल्टा एस में चेंज इन एंट्रोपी, डेल्टा एस, क्योंकि एंट्रोपी को हम एस से डिनोट करते हैं. सो दैट इज द डेल्टा एस फॉर ए सिस्टम प्रोसेस that consists of an equilibrium phase. Change depends on the value of delta H for the process. So for this process it can be given as delta S is equal to delta H upon T, where delta H is the change in enthalpy, that is heat content, divided by T. Now the expression that can be used to calculate this change for a constant pressure change of temperature is, now the expression that can be used to calculate this change, that is entropy change for a constant pressure, and change of temperature is given as, that is delta S. Delta S is equal to integration T1 to T2, integration T1 to T2 Cp divided by T into dt. So by this equation we can calculate the, that is entropy change when, that is temperature and pressure change is given. And what is T1? T1 we can take here initial pressure, initial temperature. T2 final temperature. Cp, what is Cp here? Can anybody tell me the what is Cp? Cp यानी क्या हुआ है फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स में? फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स में देखिए हम Cp, वो Cp का नाम क्या है? Cp माइनस Cv इज इक्वल टू R, ये प्रूव किए हैं, वही Cp यहां पर है. Cp मीन्स मोलार हीट कैपेसिटी एट कांस्टेंट प्रेशर. अंडरस्टैंड? सो Cp मीन्स molar heat capacity at constant pressure. So the entropy change for the isothermal expansion of an n moles, small n, of an ideal gas at a temperature T from volume V1 to V2 can be given as these are the different cases. These are the different cases of entropy change. यानी थर्मल में क्या होगा, मैकेनिकल में क्या होगा, n मोल अगर लेंगे तो क्या होगा. So these are the different cases of that is the entropy change. So it can be given as delta S is equal to nr ln of V2 upon V1, and that can be equal to, और अगर प्रेशर चेंजेस दिए हुए that can be written as nr ln P1 upon P2. So delta S is the change in entropy, n number of mole, 1 mole, 2 mole दिया हुआ, that is the number of mole, and R is, that is the gas constant. R is gas constant. We have seen what is the value of R, it is constant. हमने प्रॉब्लम में भी सॉल्व किया, कितनी है R की वैल्यू, कितना लेते हैं हम, अगर प्रॉब्लम में फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स में लिए हमने. व्हाट इज द वैल्यू, कैन एनीबॉडी टेल मी द वैल्यू ऑफ R? R की वैल्यू कितनी है? Yes,
8.314.
correct, very good, that is 8.314. So it is constant, it can be taken as 8.314. It is gas constant. Ln V2 upon V1. V2 is the final final volume and V1 is the initial volume. And if pressure is given, तो उसमें थोड़ा चेंज करना, V2 upon V1 अगर वॉल्यूम के लिए है, और अगर प्रेशर चेंजेस है तो P1 upon P2 आता है. हमने देखा है कि अकॉर्डिंग टू बॉयल्स लॉ P1 V1 is equal to P2 V2. तो P1 V2 upon V1 equal to P1 upon P2. According to Boyle's law, we have seen in octane expression for work done in isothermal reversible process. And V2 upon V1 equal to P1 upon P2. So NR ln P1 upon P2. ln is the form of log. Log की एक शक्ल है, log की शक्ल है. अगर ln को log में कन्वर्ट करना है तो कितने से मल्टीप्लाई करते हैं हम? 2.303 से. यहाँ पे अगर log लिखना है तो यहाँ पे मल्टीप्लाई करना पड़ेगा आपको 2.303, because there is a rule to convert ln into log, that is we have to multiply 2.303. Now entropy change delta S may be defined as, अब देखिए definition क्या है entropy की, जो अब तक हमने by using a graph, then different cases of entropy, and then the what is actual definition of that is the entropy, जो हमारा जो concept जो heading है आज की entropy. So entropy change that is the delta S, और simply अगर entropy है तो हम उसको S से denote करेंगे. Remember entropy change है तो delta S. May be defined as amount of heat absorbed by the system in a reversible manner. हमने देखा इससे पहले, that is the formula for entropy यहाँ पर है, देखिए that is ds is equal to, that is the dq reversible, that is amount of heat absorbed in a reversible manner, यानी reversible process, divided by what is the absolute temperature. वही definition को हमने यहाँ पे that is the wording में लिया है, that is entropy change may be defined as amount of heat absorbed by the system in a reversible manner divided by the absolute temperature. Divided by T था वहां पर, इसलिए T यानी क्या है? Absolute temperature. So divided by the absolute temperature at which heat is absorbed. So this is the definition of that is entropy. Remember that formula, delta S is equal to dq reversible upon T, formula for entropy. Previous अभी देखा हमने. So entropy change delta S may be defined as amount of heat absorbed by the system in a reversible manner divided by the absolute temperature at which heat is absorbed. So this is the concept of that is the entropy. Now next is that is the characteristic of entropy. Characteristic of entropy. What are the properties of entropy? That is, first, delta S, that is entropy change, is a definite quantity, and depends on the initial and final state of the system. That is delta S is a definite quantity and depends on the initial and final state of the system. थर्मोडायनेमिक फर्स्ट में देखा है कि जो क्वांटिटी इनिशियल और फाइनल स्टेट पर डिपेंड होती है उसे हम क्या कहते हैं, स्टेट फंक्शन कहते हैं. जो क्वांटिटी इनिशियल और फाइनल स्टेट पर डिपेंड होती है इट इज कॉल्ड एज स्टेट फंक्शन. तो यहां पर एंट्रोपी भी क्या है, दैट इज इनिशियल और फाइनल स्टेट पे डिपेंड होती है. देयरफॉर दैट इज एंट्रोपी इज ए स्टेट फंक्शन. यानी कोई भी क्वांटिटी अगर इनिशियल और फाइनल स्टेट पे डिपेंड होती है तो उसे हम क्या कहते हैं, स्टेट फंक्शन. तो यहां पर एंट्रोपी that is delta S is definite quantity and depends on the initial and final state of the system. Therefore, entropy is a state function. कोई भी quantity जो है initial और final state पे depend होती है तो हम उसे कहते हैं state function. So entropy is a state function. Next. Second, it is independent of the path by which the change in system is brought about. It is independent of the path by which the change in system is brought about. So that is this entropy is independent of the path by which the change in system is brought about. Third characteristic of entropy, the value of delta S, that is the change in entropy, remains unaltered. Unaltered means change nahi hoti. That is, and independent of the change of process, whether the change is reversible or irreversible. That is, the value of delta S. The value of delta S remains unaltered. Unaltered, that is, it does not change, and independent of the change of process, whether the change is reversible or irreversible. Next, delta S cannot be calculated from the heat absorbed in irreversible system, as the heat absorbed in the irreversible system is an uncertain quantity. So that is fourth characteristic is that is delta S cannot be calculated from the heat absorbed in the irreversible system. यानी irreversible system में हम delta S calculate नहीं कर सकते क्योंकि as the heat absorbed in irreversible system is uncertain quantity. So we cannot calculate the value of delta S, that is change in entropy in that is the irreversible process, because in irreversible process heat absorbed is uncertain quantity. So this is that is a concept of that is entropy. So I will repeat in short, that is the concept of entropy. So to explain concept of entropy, we have considered a Carnot cycle ABA consisting of two, that is isothermal and two adiabatic steps. So this is the Carnot cycle ABA. This is part first and this is the part second. And this step consists of two steps, isothermal, and here also two adiabatic steps. And then this, that is a cycle can be divided into, that is a great number of infinitesimally small Carnot cycles. So these are the infinitesimally small, that is the Carnot cycle outside the ABA. Now, entropy change can be given as, that is ds is equal to dq reversible upon t. It is important, remember this formula, that is ds is equal to dq or divided by t. And this function was introduced by, that is Clausius, and called, that is the entropy. Now different cases of entropy, that is this is entropy change in thermal surrounding. ds of system is equal to du thermal divided by T. Now entropy change in mechanical surrounding is 0, and this is the different cases of that is the entropy. Volume changes delta S is equal to T1 to T2 Cp upon T into D2, and that is for isothermal expansion delta S can be given as nR ln V2 upon V1 is equal to nR ln P1 upon P2. So entropy change delta S may be defined as amount of heat absorbed by the system in a reversible manner divided by the absolute temperature at which heat is absorbed. And these are the characteristic of that is the entropy. This is about the entropy. Okay, understand?
Yes, sir.
In the next period, we take the remaining part of the topic. Okay. If any difficulty is there, you ask in the chat box. इक्वेशंस ये नजर आ रहे हैं ना आपको, क्योंकि पीपीटी बनाने में ये इक्वेशन वहां पे टाइप नहीं हो रहे थे, इसलिए मैंने ये पीडीएफ बनाकर यहाँ पे डिस्प्ले किया हूँ. इक्वेशन आ रहे हैं ना ये नजर आपको बराबर इक्वेशंस?
जी सर आ रहे.
हाँ, वही इक्वेशन पीपीटी में नहीं हो रहे वो इक्वेशन, इसलिए मैंने फिर कल क्या किया, ये पीडीएफ बना के ये डिस्प्ले कर रहा हूँ. जो पार्ट पीपीटी में ये होगा पीपीटी में लेंगे, और जो नहीं होगा वो इस तरह से लेंगे. ओके. बाद में ये टॉपिक होने के बाद फिर बाद में बड़ा पीडीएफ करके सेंड करूंगा. अभी बना रहा हूं मैं, तो थोड़ा पीडीएफ सेंड करने में थोड़ा टाइम लगेगा. पूरा टॉपिक एक साथ दे दूंगा मैं, एक ही पीडीएफ. ओके.
ओके सर.
ओके सर.
जी सर चलेगा.
Okay, then we will stop. If you have any difficulty, write down in the chat box. Otherwise,
No sir.
Okay, we will stop here.
No sir.
Okay, we will stop. Thank you.
अल्लाह हाफिज सर.
Okay, Allah Hafiz.